So here from section 1.2, we have this mixing problem. And then we say that there's a large vat containing sugar water that is to be made into soft drinks. So before we begin this problem, let's consider that we know that there's always going to be 100 gallons of liquid in this tank. So there's some amount coming in at pipe A and some amount coming in pipe B, but that same amount is coming out at pipe C, so we always have 100 gallons. And what we want to do is figure out an equation so that we can model the situation in which we want to figure out how much sugar is going to be in this vat at some time t. So to do that, let's figure out what our independent variable and our dependent variable is first. Well, our independent variable is going to be time, and we want to figure out how much sugar is in this tank at some time. So let's look for S of t. So when we try to solve this ds of dt, we're looking for the amount coming in minus the amount coming out. That's all we have to do. I think what'll make this problem easier is if you just think about units. What you're doing. So we have some amount coming in at pipe A and B and out at C. So let me scroll over here. All right, so it says that at pipe A, we have 5 tablespoons of sugar per gallon entering the vat, and it's coming in at a rate of 2 gallons per minute. So we have 5 sugars. We're not going to write tablespoons. Let me just write, let me write tablespoons. Times 2, there's gallons per minute. All right, what else? Plus, pipe B, we have 10 tablespoons, just at a rate of 1 gallon per minute. All right, so per minute, t, our independent variable we should specify, is going to be in minutes. We have 20 coming in minus what's coming out. Now, thinking about what comes out, that isn't like explicitly stated as it is for pipe B and pipe A. We just know that at pipe C, the liquid's leaving at a rate of 3 gallons per minute. But what we also know is that this solution is being mixed as it's coming in, and so we can think of a way to express this amount that's coming out. So we don't know a total amount, but we do see that there's some amount of sugar, S of t, right, out of 100 gallons, right? Because these are 5 tablespoons, and it's coming in through via 2 gallons, 10 tablespoons per this gallon. So we have S of t over 100 gallons in the vat. And this is coming out at a rate of 3 gallons per minute. So let's write this 3 right here. All right, so now we have our ds over dt set up. That's equal to 20 minus 3 S of t over 100. Simplify this a bit more. Oh, sorry about that. Okay, now we can get our S on one side and our t on the other. And I'm going to go ahead and start writing this S of t. It's just S. So we have 1 over 2,000 minus 3s is equal to dt over 100. Now let's go ahead and integrate both sides. And we're going to see that negative 1/3 times the natural log of the absolute value. Do not forget the absolute value bars. We'll explain more in a second. It's equal to t over 100 plus c. Okay, and I'm just going to go ahead and simplify the rest of this problem. Next, we're going to have natural log of the absolute value, 2,000 minus 3s. Sorry about this. Is equal to negative 0.03 plus, let's just write this at C1, right? Because we're multiplying by this negative 1/3, or negative 3, excuse me. Okay. Next, we need to exponentiate both sides. Okay. Now we can bring this this c up to the front. All right. And we can go ahead and get rid of these absolute value bars. So we have 2000 minus 3s. So we know that that would be plus minus, and of course this would, which one we'd use would depend on what value of s we would have. If f's was less than 2000 over 3, we would have a positive. We choose the positive value. This refers back to the first video I made and where we solved those equilibrium solutions. Let's go ahead and write a C2 0.3 t. Okay, so minus 3s equals C2 e to the negative 0.03 t minus 2000. S is equal to, well, really this would be a C4, right? C3, I guess. C3 e to the negative 0.03 t plus 2000 over 3. So this gives us our general solution for this problem. Thank you for watching. I hope you